Now we're going to move on to thermal regulation. So when you thermal regulate, you're controlling the body temperature. And all animals exchange heat with their environment. So heat flows from downhill regions of higher temperature to regions of lower temperature. And the mechanisms of heat exchange are conduction, convection, radiation, and evaporation. So we're going to look at each of these in turn. So conduction is when there's a heat transfer between two physical uh, bodies. Okay, so in this example with this turtle here, it would be the heat transfer between the turtle and the rock. So if the rock is warm, then the heat, since it moves downhill, it'll transfer from the rock to the turtle. Convection is a type of conduction, but this is between a um, physical body and either a gas or a liquid. Okay. So in this case, it would be between the turtle and something like the wind or rain, right? Or it could be water. And radiation is the heat exchange between the direct heat exchange between two bodies that are not in physical contact with each other. So it could be like the sun and an animal, or it could be another heat source like a like a burning fire pit. When if you're warming up your hands in a burning fire pit, that's radiation because it's the heat exchange between two things that are not in physical contact with each other. And then there's evaporation. That's the exchange in heat or the heat loss that is caused by the evaporation of water or something going from a liquid to a gas. Okay. So thermal regulation varies in different animals. So an animal that's an endotherm is an animal that produces enough heat to warm its own tissue, like most mammals, although not all the mammals. An animal that's an ectotherm relies on the heat that is gained from the environment. Okay, so these classifications are based on how the animal is able to obtain the heat. Is it producing it or is it obtaining it from the environment? Right. So if it's producing its own heat, it's an endotherm. If it's getting it from the environment that it's in, it's an ectotherm. And then you can also see how that temperature is held. If it's constant, then it's classified as a homeotherm because these keep their body temperature constant. If it's if it varies depending on the environment, then it's classified as a poikilotherm. So an animal can be both things. It could be a homeotherm or an endotherm homeotherm, right? It can be both. It could also be a, you know, uh, poikilotherm, ectotherm. Okay, so humans are endothermic homeotherms because we generate our own heat and the temperature is maintained at a constant level. Okay. But many animals lie somewhere in between these extremes. So, for example, an African elephant can allow the body temperature to rise during the hotter part of the day. And so, in this case, it would be a poikilotherm. So, it would be an endothermic poikilotherm. And then you can also see this in things like Japanese honeybees that exhibit poikilothermy when they are defending their hives from predatory hornets, like the Japanese giant hornet. So when this happens, a hornet because these prey on honeybees. So when they find the hive, if it's just a single honeybee, it'll eat it or it'll kill it. When it finds a hive, in order to protect the hive, the honeybees they surround the hornet and then they raise their body temperature to a level that the hornet cannot withstand. And so essentially they bake it. Okay. So in this case, the honeybees are exhibiting poikilothermy. Torpor and hibernation are similar. It just depends on how long that that drop in body temperature happens. So torpor, it would be a temporary drop in body temperature. So you can see this with things uh, like hamsters during the during the winter time. If the temperature drops too low in the room that they're kept in, it'll go into torpor for a little while. But then when it warms up again, it'll come out of it. Hibernation is just a like a very prolonged uh, period where the animal is inactive. And then estivation is just a prolonged torpor that's used to escape dry or hot conditions. And small mammals that inhabit cold climates will lose heat rapidly because their surface area is large relative to their volume, right? They have a high surface area to volume ratio. So to survive these cold temperatures, animals like dormice reduce their metabolic rate and allow their body temperature to drop. So another example of poikilothermy, maintaining the body temperature depending on the environment, right? Endotherms can warm themselves because their basal metabolic rates are very high, and heat is given off by the high rate of chemical reactions, and so this is enough to warm the body. And mammals and birds retain their heat because they have insulating structures like feathers or fur. And ectotherms, they gain their heat directly from the environment, and only a small amount of heat is a byproduct of the metabolism. So they have a slower metabolism that doesn't generate enough heat. And most heat is gained by radiation or conduction. So either by basking in the sun, right? So taking in the heat from the sun or getting it from a hot rock. Endothermy and ectothermy can be best understood as contrasting adaptive strategies. Endotherms have a higher metabolic rate, so that means that they can be active for longer periods of time. So either day or night, they can be active, foraging for food or whatnot. But this costs a lot of energy and focuses that energy on producing heat versus other energy demanding processes. So it could be other things like either, I don't know, immune response or reproductive uh, abilities. Ectotherms are able to thrive with much lower intakes of food, and they can use a greater portion of their total energy to support reproduction. And but the downside of being an ectotherm is that the muscle activity and digestion uh, is slow or slows down as the body temperature drops, and it makes them vulnerable during the cold because they're not able to escape. And you've probably seen this, like if you've ever run into like a lizard in the morning, that they're not as fast as they would be in the middle of the day. So Some animal structures conserve heat with the countercurrent heat exchangers. So these are arteries um, that are wrapped with several veins. So they're arranged in an anti-parallel uh, arrangement. Okay, so they're next to each other, but the blood flow is going in opposite directions. So the heat flows freely from the warm arteries to the cold veins, and thus they retain more heat. So the countercurrent exchangers are efficient and they maintain a gradient between the two fluids along their entire length. And you can see this with things like it's very common in mammals, especially at the extreme ends of the bodies where there's they would be able to, or they would lose a lot of heat. So you can see this in whales in their tongue area because the way that the whales feed is they take in a lot of water. So to prevent the blood from cooling too much or getting too cold as it goes back into the body, they have this countercurrent uh, exchange. So the arteries are carrying the blood from the body to the rest, or from the heart to the rest of the body, so it's coming in warm. And then the veins are returning that deoxygenated blood back to the heart. Okay, but it would be a lot cooler at the end of the body. But with this countercurrent heat exchange, as the warm blood is going out and the cool blood is going in, since heat travels in a downhill, uh, it travels downhill, it goes from high to low. The warm blood from the arteries will warm the cooler blood from the veins as it returns to the body or to the heart. So you can also see this in, like I said, like in other mammals at the extremities. Like you could see that in your hands. Um, Birds also have this at their feet. So it's very common in in warm-blooded animals. All right, so that would be it for this chapter, and we'll continue on the next one.